Welcome to In This Tech, and welcome to this SolidWorks tutorial. My name is Atang Okwong, and welcome to my presentation. Today we shall be learning about even more SolidWorks features and functions by designing this kitchen sink assembly that you see before you. This assembly is made up of the kitchen sink, the faucet handle, the cabinet, and the cabinet door. We will be designing each of these components and learning more about SolidWorks as we go along. So without further ado, let us quickly dive in and start our new part. I'm going to select a plane, the top plane. Sketch a rectangle on it. Dimension the rectangle 600 by 580. Then I'm going to extrude it by 34 mm. Next, I'm going to use the convert entities tool here. Using the convert entities tool, I'm going to convert this line, this edge, into lines. And I'm going to use the extrude boss base to extrude the lines. Alright, so after clicking on convert entity on here and here, to convert those edges into sketches, when I click on extrude boss, I click on midplane, and so I yes, midplane, and I proceed to do this so that it will align. Okay, there we go. So, yeah, just taking shape. The next thing we will do is to draw an ellipse right here on the surface. Okay, I'm going to draw the ellipse. We will start somewhere in the middle. Here. Okay, hold on. Let me try and get it a bit lower. Okay. Yeah, this looks This looks okay. And then we're going to use a cut extrude to create a hole in that. There you go. A hole has been created. I'm also going to, for sake of, get a center line here. Because I want to get a hole I'm going to use for the faucets. Hole I'm going to use to install the faucet. Okay. Oh, I think I chose the wrong feature there. Extruded cut. Okay. Okay, and that's cut right through. Alright, next thing we are going to do is to create a reference plane. Reference geometry. Let's make it 150 from the top plane. The top plane is our reference. Oh, wrong side. Edit the feature. Flip the offset. Yes. That looks good. Okay, now I'm going to sketch on this plane a circle. I want that circle to be somewhere here at the middle of this. So let's put the circle here, a small circle, dimension it to be, yeah, 16, 70 is good. Now what we're going to do is I'm going to make a loft, create a loft, between this. Okay, you can see that. You can see that SolidWorks has already shown us the preview of the loft. This is not what we want. Kitchen sinks are not shaped like funnels. They are a big curve. So we are going to include start and end constraints to curve the preview a bit. Okay, so we use start and end constraints to make this to look a bit better on the more eccentricity. Okay, there we go. You can see that it's a bit more curved. Yeah, so this is the finished loft. Starting to look a lot like a kitchen sink now. Now if I'm going to use the shell property or the shell feature to create a hole in this 10 mm thing, it's too big. So yes, you can see that there is a hole in this now. So yeah, I like to include fillets to smoothing my edges. Here as well. Okay. Let's make it a 5 mm flat. So it's not too big. Very good. Very good. And then we will also make fillets here. And here. And this face as well. Tucked. Excellent. Okay, it's looking good now. All the edges are filleted, and our sink is looking nice. Okay, now for the next part, the faucet. I'm also going to make the drawing from the top plane. I'm going to be starting with the slot feature. And then I'm going to make this symbol, something like that. Okay, so now slug it from here. This, this, and 60. Close, and let's extrude it by say 15 mm, 15 mm, then once you draw circles, at the back, see how SolidWorks helps us to identify the center quickly. I don't make any mistakes. See? 20. Next, we extrude. Let's extrude by say 40. So it's like, so you can see that. 50 is good. Then we are going to draw the, still not done, so I'm going to create a sketch on this. This is fine, the middle, and then draw a circle. I'm going to dimension it 30. Then we're going to extrude it about 15 mm. That's good. Then we will draw another circle on this face, having the diameter of around 12 volt. I don't think it's, oh, it's not concentric. Okay. Now, another circle. The diameter of this should be 25. We'll extrude this one to like 50. Let's say 40. Then I'm going to draw another circle. Between 20. Now we are going to need a reference plane for us to be able to proceed to the next part of the sketch. If I click on reference, you have to exit the sketch first. The right plane is going to be our reference plane, and it's going to be 10. No, it needs to be right at the middle. Yep, right there. That is where we need it to be. So I'm going to do a sketch on that plane. Okay, so I'm going to be using the spline tool. Okay, using the spline tool, we shall be creating these curves that we need. I'm gonna adjust the curvature so let us I'm going to make a coincident mate between a coincident relation between these 2 points. It is very important that they are coincident, because now we're going to be making a sweep using this circular sketch profile. And this, there we go. Yeah, we have a very nice sweep here. We can as well choose to add some more features to this to make it look better. I'm going to come here and convert Okay, so let's zoom in on the face. I'm going to draw a circle of about a circle of about 15 mm. Sorry, no, 25 mm, 25, and then you're going to extrude it in the reverse direction. Yeah, I'm going to create a 5 mm shell somewhere. Okay, consider it passes through and goes down to the end for water to come out. Or let us add some fillets to make the whole thing look a tad bit neater. 10 mm is too much. Let's go 5. Or 3. Then we fillet all these two. Yeah. To give the whole thing a nice finishing. Next we will design the faucet handles. Next we are going to be designing the faucet handle. For the faucet handle, we will be using the front plane. I'm going to create a sketch like so. I'll make this a bit longer. Okay, this is a sketch. Then I'm going to do a revolve using the revolve boss, revolving around. Oh, hold up, forgot something. It's supposed to be a center line. Okay, now we have a center line. We'll be able to do our revolve boss now. Hold on, looks like we need to check us. Okay, so I removed the center line. I'm going to try the revolve boss again. Okay, good. So this is our a part of our um, uh, faucet handle. Next, we're going to do another sketch. Another sketch like so. On the pick the front plane, sketch, and then I'll draw this shape. I draw a line like this, then draw another up to here, and up to here, like so. Okay, now I am going to create a couple of okay, so like this. I'm using the spline tool again. I will Okay, this looks good. Now we're just going to do a quick revolve. Another revolve. The August revolution is here. Yep, there we go. Our faucet handle. I'm going to add some fillets to make it a bit more get a bit nicer. Yes, 5 mm fillet is good enough. Or 6 mm. Let's see what that looks like. Okay, not bad. Yeah. So that will be all for this video. In our next video, we are going to design the cabinet door. We are going to design the cabinet. So we are going to design hinges probably. Please, hope you enjoyed the video. Don't forget to like and subscribe and comment as well. Thank you. Hello and welcome to In This Tech. My name is Okwong and welcome to this SolidWorks tutorial. Today we shall be talking about SolidWorks assemblies, and we shall learn more about assemblies by continuing from our last two videos, the assembly of this kitchen sink. From our last videos, we had designed the sink, the door mold, the short door mold, the faucet, the faucet handle, the cabinet, and the cabinet doors. We are going to assemble these parts to form this kitchen sink assembly, and we are going to learn more about SolidWorks assembly as we progress. We are going to talk about assemblies, what assembly is, assembly design methods, how to prepare for an assembly, mates, in context design, and how to examine the assembly. An assembly is a collection of related parts in one SolidWorks document. They can contain anywhere from 2 to over 2,000 components, which can be parts, other assemblies, or sub-assemblies. They can also display movement between related parts within their degrees of freedom. The components in an assembly are defined in relation to each other using assembly mates. You can attach assembly components using various types of mates such as coincident mates, concentric mates, and distance mates. So without further ado, let us start the assembly of these components. What I'm going to do is click on File and click on Make Assembly from Part and click OK. Now, because I already opened the components before, they are already outlined here in this menu, so I can select the parts and bring them into the graphic design area. Now, there are two methods usually used for assembly design. The first is the bottom up design, and the second is the top down design. In the bottom up design, which we are going to be using now, you create the parts and insert them into the assembly. But with the top down design, you create the parts within the assembly. So you open an assembly file first, and then you create the parts in the assembly file. Now I'm going to insert the components, and we are going to start assembling them. I will start with the faucet. I click on the faucet and I tap on the graphic area and it imports. Next, I'm going to insert new components. Click on insert components here, and then I will insert the faucet handle. I can choose to copy this part because we need two faucet handles. I can choose to copy this part. If I click on Ctrl C and I click on Ctrl plus V, the part pastes. I can also choose to insert the part again, and then since it's facing the wrong way, I want to rotate it. There we go. So it's facing this side now. Now we are going to attach these handles to this surface using mates. Mates are going to help us to position the components of an assembly precisely with respect to each other. So I want to click on mate. I'll click on this face and click on this face, and you see what happens. They move together to connect. Now you can see it is in the wrong position. Most times, often, it is required that you use more than one mate to fully define a part in an assembly. So I'm going to use another mate. I'm going to mate this part, this face here, with this one. You see, we get a concentric mate in this position, and that allows us to be able to rotate it. If I want to click OK now for the concentric mate, there we go. We can see it rotates only. It doesn't move up, it doesn't go down. All it does is move and rotate. I'm going to do the same thing here. I'm meeting this face with this one. You can see it moves down. After this mate, the rotation is irregular. This is not what we want. We want this to move only in a rotationary direction. So I will be adding the same mates as I did before to the other faucet handle. This one and this one, a concentric mate. And voila, we have our faucet
assembly complete. Now I'm going to insert the sink. Insert components, sink. I'm going to bring it here. Okay. We're going to need to attach this faucet to this sink. We're going to have to add a mate. One of the first mates we'll add is a coincident mate. I'm going to make this face to be coincident with this face. That means that this face is going to be touching that face. However, hold on. However, as you can see, this is in the wrong position. I'm going to have to delete that mate and mate these components again. Since I want this to be in this hole, I'm going to mate this face with this hole in here. And then this cylindrical face with this hole here. A parallel mate. SolidWorks will automatically select the mate that best applies to the parts that you want to connect. So we have here a parallel mate, and that's what we want, a parallel mate. Now, if I select a coincident mate in this condition, you can see that it aligns perfectly. And this is what we want. This is what we want. Hold on, let me just straighten this. Okay. Now I'm going to add the cabinet. Insert components and add cabinet. Let me rotate this. Okay. Good. I'm going to add coincident mates to help us to define it properly. So I will mate not the edge. I want to mate this face and this one in here. I also want to mate this face and this one in here. Look at what we have. But then this assembly is not yet fully defined. There are irregularities in the movement. I want to use mates to fix that. Now, this is rotating. It is wrong. We do not want it to rotate. So what I'm going to do is I am going to go back to the mate. and delete it. I will create a new meet. Here, edit it, and click on lock rotation. By clicking on lock rotation, I'm ensuring that it will not be able to rotate. As you can see, it does not rotate anymore. So yes, we're good to go. So I'm going to add my mates again, mating this face and this one, a coincident mate. Then I'll mate this face and this one. Now we don't want these to come out like this, so I'm going to create a mate between this face and the one at the bottom. I'm going to make a distance mate. Let's give it 920. It still comes out a little, so let's make it 910. Okay, 905 this time. And there we have it. It's in there. To come back quite a bit, so 903 mm. Okay, it's better now. There you go. We have our mate. But if you observe, you can see that there's an error here. The sink is not quite matched with this, so we're going to have to edit one of these components so that it can fit in properly, because this is not right. How do we do that? Does that mean that we are going to have to start again and from the beginning and do the design? No. So SolidWorks allows what we call in context assembly, where I can edit the components within the context of the assembly. So I'm going to save it. Let's call it sync the video. Save all. I can choose to edit this feature. Edit the component rather. I'm going to come here. In our last video, we used a shell to make this hole in the cabinet. So I can change this to 20 and it will adjust within the context of the design. If I click on exit, we can see that. Where is it? It is almost there, but it is not. So I'm going to have to edit the size of the sink. Okay, so now I'm going to click on this face, click on edit sketch. Let's make it 575. There you go. Okay, it fits a lot better now. It is no longer inserting itself into the wooden parts of the assembly. Alright then, we're almost done. Now I'm going to insert the door assembly. Where is it? Cabinet door. Okay, hold on, it just happened. Okay, it seems to have fixed itself. So yeah, now we are going to insert the door molds, insert components. Insert the mold. Okay, I'm going to rotate it. Rotate it again. Okay. Now I'm going to mate this. After going to make these edges a coincident mate between the edges. Let's see what that. Okay. Now I am going to mate these edges. This. And what's that one? This, yes. Coincident. Okay, very good. And after doing that, they will observe that the other edge is not touching this edge. This gives us the opportunity to perform another in context edit. So I will take this part, click on, because in our last video we extruded to get this component. So I am going to click on edit the feature and make it 814, for instance. Oh, as you can see, that was not enough. Let's go again. Edit the feature. 820, 824, 825. Okay, looks like it is coincident now. And there we go. We're able to get it to coincide. With the other. Okay, so we have a problem down here. Let me sort it out. Okay, so our mate was not fully defined. That is why it's stretched to that end when I increased it to 828. So what I'm going to do is I'm going to take it back to 814, and then I am going to add another mate. Oh, it's already aligned now, but still important. I do this to make it more defined. Okay, let's see what's going on at the top. Okay, perfect. It's aligned now. So what I'm going to do is I will copy this path, Ctrl C, Ctrl V, or I can just insert it. Let me add the necessary mates. This one to this edge. This edge and this edge coincident. And there we go, we have our mates added. Now for the short door molds. I'm going to come here and rotate it. Okay. Let's see what we have here. It is not long enough. So I'm going to perform another in context edit. Let's make this 414. We mate one face first. Oh no. I'm going to add the mate between this face and no, this face. Then add one between this edge and this edge. Okay, then everything is properly aligned. So I will just do the same thing at the bottom and set components, short mode video. Where is the component? Okay. Rotate. Rotate. Insert. Now time for the mates. This one. And that, yes. And then I will make this face and this face. There we go. We have finished the door assembly. Now we are going to mate this face with this one here, and this face with my battery is low. This one here. Then you can see that it is still moving, so we need to properly define the mates. I will then mate this edge with this edge right there. So yeah, the component, it says that the component is fully defined, so it cannot be moved here. So yep, this is our assembly. We're able to do in context designs and learn more about meats by carrying out this simple sink assembly. It is also possible to hide or show components. I can choose to hide this. I can choose to hide this. I can choose to hide this as well. It's easier. It helps when you want to create mates or when you want to examine a part properly. When you use this hide or show tools, you can also create an exploded view of the component. To make an exploded view, you simply select the component, click on exploded view, select, click on done, click on the other, select, click done, the other component, select, click done, this as well, done, then can click on this, okay, you can click done. You can do the same thing here and click done. And we're left with the last part. Now just bring it down a little so it doesn't feel left behind. Click done. Yeah. So if I go to configuration, click on exploded view, I can choose to animate the collapse. So yeah, this is what SolidWorks assembly allows us to do. In our next video, we're going to learn how to make drawings from parts. We're going to make 2D drawings. That is drawings, or let's call them schematic diagrams. From this part, we'll make a schematic diagram or a drawing from this, more like a blueprint, more or less, for this part in our next video. So stay tuned and subscribe, leave a comment, like and share. Thank you for watching.
Hello everyone and welcome to In This Tech. My name is Okwong and welcome to this SolidWorks tutorial. Today we are going to learn about drawings in SolidWorks. We'll learn about drawing documents by making a drawing out of this cabinet that we created in our last video. You can see I have it on the screen, a drawing of the exploded view of this cabinet. We shall learn about how I made this drawing, or how to make a drawing like this, and other drawings in SolidWorks. We'll also learn about what drawings are and how to make drawing documents and the various types of drawing documents. So without further ado, let us proceed with the drawings. First of all, a drawing is a 2D document as is used to convey a design to manufacturing. When you want to manufacture a product, you give the design to the manufacturing department, and they are the ones that will bring this design to life through the drawing. You can, in SolidWorks, you create drawings from drawing templates. I'm going to open the sink assembly that we made, and I'm going to create a drawing from this. To create drawings from this, I go to File and click on Make Drawing from Assembly. Now these are drawing templates: A landscape, A portrait, A ANSI landscape, C ANSI landscape. These are drawing templates. Now inside these templates are drawing sheets. Now it's important to remember that drawing sheets and drawing templates are two distinct entities. The software comes with a drawing template and a set of sheet formats. Now I will select this template, and this is the sheet that we have in it. Now this is the drawing sheet that we have in front of us. If you observe, at the bottom right of the sheet is what we call the title block. The title block tells us information about the drawing. Tells us the number of sheets in the drawing, the title of the drawing, and the scale of the drawing. Now it is possible to edit the sheet format. I can decide to add a title. I'll call this Sink Drawing. I'll remove this one and say number 1. The scale is 1 to 10. I can add a name, I can add dates. There are other things I could add as well. Add my name, drawn by so yes, it's also possible to edit the border, but we don't want to do that. We just want to focus on what we have here. Alright, now I'm going to insert a drawing. So I have to exit this one first. I'm going to now insert a component to make a drawing from. Let me insert the isometric exploded. The drawing views are here. I can insert drawings from here, the view palette, then I drag it. As you can see, it has become a drawing. I can choose to edit the display style. If I click on this, you can see that the hidden lines become more visible. If I click this, the drawing becomes like that. I could change it to draft quality, and if you notice, the quality of the drawing changes as well. Alright, however, we want it in high quality, want it the here in this format so that the hidden lines are visible. I could choose to change the scale for this drawing and use a custom scale of say 1 to 3. See, it becomes bigger. 1 to 10 comes like this, or let's say 1 to 13, it becomes smaller. Okay, that's about that. Then I want to insert another view. I want to insert this. Bring it here. Alright, then we can see that it is in this format. However, I want this one to be like this. There we go. I'm going to move it a little bit downward. As you can see, they move together because they are linked. Alright, so this is how we make a drawing from this. This is the basic. Now I want to make another drawing of the cabinet, of the components, or a few components, starting from the cabinet. So I'll click on here, add a sheet. Then I'm going to come here to the view palette and click on this for the cabinet. And I can see that all the views for the cabinet are shown. So you can see the drawing views for this component. Drawing views are placed on drawing sheets and they contain images of the models along with dimensions and annotations. Drawings begin with standard views, and from these views you can derive other types of views such as projected view, section view, and detail view that you can see in the top right where the arrow is right there. We are going to start talking about the standard views now. We're talking about the standard 3 views. The standard 3 views, as the name implies, comprises of 3 different views: the front view, the top view, and the right view for third angle projection, or the front view, the top view, and the left view for first angle projection. In first angle projection, the front view is displayed on the upper left, and in third angle projection, the front view is displayed at the lower left. SolidWorks uses this drawing uses first angle projection. However, it is possible to change it to third angle projection. You click on settings, go to display, then click on third angle here. If it's in third angle, you go to first angle. I want to use first angle projection, so if I click on standard 3 view and come, okay, go to the cabinet, click on this. Our 3 views are visible here. I can choose to, this is the top view, this is the front view, and this is the right view. I can choose to edit these views and add hidden lines visible to it. Hidden lines visible. Okay, here it is.
Good. Now, these standard three views is just an easy way of bringing all three views at the same time, and they are all linked together, so they move at the same time. I could have also brought each of these views one by one through the view palette here. Now let's talk about projected views. Talk about projected views. I will click on projected view here. As you can see, the views are already projecting. Click on this. This is the isometric view of the part. I can also project from here. It gives another angle. However, we don't want that. This is the front view, projected. As you can see, it's the same thing as this one. This is the view from the other angle. I could also project from here. This is the back view, as you can see from the hidden lines. So yes, that's all about projected views. Let me bring these closer together. Okay. Now let us talk about dimensions. Dimensions in SolidWorks are associated with the model, and the changes in the model are reflected in the drawing. If I change the dimension in the model, it would also change in the drawing. You can add dimensions to a drawing, however, these are reference dimensions and are driven. You cannot edit the value of reference dimensions to change the model. The value of the reference dimension changes when the model dimensions also change. What that means simply is that I can add dimensions to this drawing here. However, I cannot change the dimension of the parts, change the dimensions of the model from this drawing. All I can do is add the dimension. Simple as that. Now I can choose to insert model items. It is a faster way of inserting dimensions into the drawing. I could simply add this. Yes, the dimensions have all been added. I can choose to edit the dimension here. I want to edit the text because this text is too small. So I'm going to edit it. Click on other, say uncheck use document font. Click on font, change it to 7. When I come back out, it becomes bigger. I can do the same thing for the others here. Seven. This is so that we can be able to see the dimensions clearly as we are working on it. Okay, now I could have inserted these dimensions myself, which I will do with this one. But that is a long process. Using insert model items makes it a lot faster and easier than having to do this for all of the designs, all of the drawings. Okay, so that's it for the cabinet drawings. We have brought out everything and label and the added dimensions. I can now choose to add a title here. I can say edit sheet format, remove this, make it drawing number 2, add a title. It says cabinet. First we add the exploded view of the isometric. Let's make it a bit bigger. Change the scale to 1:8. 1:5. Not quite big enough. 1:3 then. Okay. We can work with this. Change the display style to make hidden lines visible. Make a draft quality. Nope. High quality is better. Keep it like this. Move it up a bit. Now we're going to talk about. Okay, first let me add this view. The view from the top. I'll do the same thing as I did before. Change it to a custom scale, 1:3. Smooth this out a bit. Now we'll talk about derived views. Derived views are created from the standard views. With the standard 3 views or a named view in a drawing, you can create other views without going back to the model. For example, you can create a sectioned view. If I click on section view, like so, click on OK, click on auto hatching. I have created a section view of this. I can choose to flip the direction. I think this would be much better. Like this. If I zoom in, you can see that this is a section of this. You can see the insides and everything that is a part of this. You can see the caption is there, section AA, scale 1:3. I can choose to edit the font size, make it 7. Yes, there we go. Next we have detailed views. Detailed views. To do that, I click on detailed view and I sketch a circle around where I want my detail to appear from. and I draw it down, I can decide to make an outline. Full outline, yes, like so. Edit the document font, make it 7, and then we have a detailed view of this component here. Whatever was here, so we have in our detailed view here. Next, we can have what we call additional drawing views or alternate position views. I am going to insert another top view here, change the scale, and click on OK. I will now click on alternate position view. This will create a new position, and change this to this, and change this one to this. I click on OK. If I go back to the sheet, you can see that it has given us a new view for if maybe the tab is on and it changes position like so. Alright, so let me take this a bit higher. Okay. Alright. Now we're going to talk about notes and a few other annotations. So now I'm going to add a note somewhere here. Say 90-degree rotation for full open valves. So yeah, that's basically everything about these views. I can choose to edit the sheet format again, add my title, make this drawing number 3, make this faucet assembly drawing. Yeah, exit that. Now we have it saved. Now let's go back to our first sheet. Here we have our exploded view of the drawing. We are going to add something called balloons to each of these parts. Number 3, 4, 5, 6. Now with these balloons, we can use them to insert what they call a bill of materials. We're going to use the balloons to insert a bill of materials into the drawing. A bill of materials is a table that lists the components of an assembly along with some information needed in the manufacturing processes. If the assembly or its components change, the bill of material updates automatically to reflect the changes. I am going to click on Insert, Tables, Bill of Materials. It says I should select the drawing view, specify the model for creating a bill of materials. I click on this, click on Standard, click on Attach the anchor point. Start as 1, increment by 1. Oh, very good. I come to the drawing sheet, click OK, and there you go. I can choose to increase the size. I can also highlight everything, click on this, use document font, and click on 7 to make everything bigger. There we go. This is, you can also edit it, you can change anything in it. But yeah, this is the basics of creating a drawing in SolidWorks from an assembly. Thank you for watching the video. Please leave a like, subscribe to the channel, comment, and share with your friends.